Okay, developers, welcome back. Now, I was doing some smart contract security homework and I came across an example of an apparently super famous hack. It's one that will go down in history because the way in which it happened was just pure carelessness. If you're new here, I'm Calvin Torah, and on Eat the Blocks, we help Web 2 developers transition into Web 3. It happened to a project called Rubixi. This is basically a Ponzi game where users send Ether to a contract, and after some fees were collected and calculations were done, you'd hope to receive a payout next time someone else pays in. It sounds super dodgy to me, but some people just can't resist a quick win. The original contract can be viewed on Etherscan, but to show you what happened, here's a simplified example. See if you can spot the problem before I explain it. Here we have a random contract called the allocations contract. We're going to use safe math from OpenZeppelin because we're smart. We have our mapping for allocations of funds, and we have the owner of the contract. Now this hack happened on an older contract, so in the past your constructor had to have the same name as the contract. That's how the EVM knew what to use. We set the owner and add the initial funds. Then we set up the only owner modifier to make sure only the owner of the contract can do special actions. We'll set up some random functions, one that adds funds to our mapping, one to check balances, one to withdraw our funds, and another to withdraw the funds of the entire contract itself, but only the owner can use this one. Then we'll deploy our simplified contract using Remix, and you may immediately see what's wrong. If not, we'll get to that in a second. So let's send some funds into the contract using the allocate function. We're going to send 1 Ether and hit allocate. Then we'll check the funds that I have using the allocator balance and my address. And we can see I have 1 Ether. Perfect. Now, if I try to collect all of the allocations, we can see in the error that I am not the owner, so I can't perform this action. And here is where we'll look at the hack. We can see we've got a button here to call the constructor, or what we thought was the constructor. So if we go to the owner button, we'll see that my address is not the owner. However, if I call the constructor function and then check the owner again, we can see that I am now the owner of the contract. I can now hit collect allocations again and drain the entire contract of funds, and now it belongs to me. Turns out this is where Rubixi messed up. I guess during a refactor of the code, they renamed their contract but didn't update the constructor to match it exactly. You can see my obvious error here where I have accidentally spelt the constructor with a 1 instead of an L. Because the contract name and constructor name didn't match exactly, their contract was deployed, and what they thought was the constructor actually became a regular function, meaning anyone can call it and become the owner. Luckily, as of right now, we no longer are creating constructors in the same way. We now have a reserved name or function specifically called constructor, which we use during deployment, but this still teaches us a valuable lesson. This is not just about the constructor syntax. We need to double check, maybe even quadruple check every aspect of our code when deploying to mainnet, and look for ways that bad actors can manipulate our code and claim ownership of our contracts. That's all I have for this video. Thank you for watching. I hope you learned something new, and check out this video for more Solidity best practices, and I'll speak to you soon.